All right, now we're going to look at the Unit 4 constructed response for the practice test. We look at the first item here. We're going to tell whether the system has one solution, infinitely solution, or many solutions. I'm going to show you, first we'll start by trying to solve it. So look at the first one here. I'm looking and thinking, okay, I've got a minus and a plus here. So I'm going to solve this by multiplying the bottom equation by 3. The reason for that is that will give me 3y, and the minus 3y will cancel out. So at this point here, let's write this one down here, x minus 3y equals 2, and then multiply each of those by 3, and we get 9x minus 3y, plus 3y, excuse me, equals 6. Now, as we expected, those will cancel out. Minus 3 and plus 3 is 0. So we end up with 10x equals 8. Undo 10 times x by dividing by 10. And we end up with x equals 8/10 or 4/5. Now at this point we could plug this back in and find y, but our question is, does the system have one solution, infinitely many solutions, or no? Since I found the point at which there is a solution, I can just simply write down one solution. Okay? Now there is another way to do this. I could look at these equations and compare their slopes and intercept. For example, if I took this equation and I solved it for y, I would subtract x, minus 3y equals minus x plus 2, divide by minus 3, everything, and I would get y equals a negative by negative is a positive 1/3 x minus 2/3. So I have a slope of 1/3, a y-intercept of minus 3. Now let's compare the other problem. 3x plus y equals 2. Subtract 3x from both sides. We get y equals minus 3x plus 2. Notice my slope here is negative 3, and that slope was 1/3. These would actually be opposite reciprocals, which means these two lines are perpendicular. So that means because they're perpendicular, they're going to cross someplace. And so, as we said, there is one solution to this equation. Let's try number 11. This time I'm looking to solve, and I see a 3 and a 6. I'm looking here, this would be easy. I got an x and a 2x. So if I multiply this one by minus 2, I'll get negative 2x, and 2x will cancel out. So let's do that. Negative 2, so negative 2x minus 6y equals minus 14. And then the other one we didn't change. And now we'll add them together. As expected, that cancels out. But we didn't expect this. Negative 6 and 6y also cancel out. So on this side of the equation, I'm just left with 0. So 0 equals minus 4. Then the question is, when does 0 equal minus 4? Never. It doesn't equal. So when you are working a problem and you end up with that solution, a false statement, you know that there's no solution to the problem, because there's never a time when 0 equals minus 4. So that is no solution. Okay? And we could check that out the other way if you wanted to work it the other way. Solve them both for y and compare slopes. So if I take x plus 3y equals 7, I subtract x, I get 3y equals minus x plus 7. Divide by 3, everything. I get y equals minus 1/3 x plus 7/3. And then we do the other side here. We get 2x plus 6y equal 10. Subtract 2x. 6y equals minus 2x plus 10. Divide by everything by 6. So we can get the y by itself. And 2 divided by 3 is 1/3, so minus 1/3 x plus 5/3. Now that we look at them, notice that the slope there and the slope there are the same. That means these two lines are parallel. They have a different y-intercept, so they're not the same line, but they're parallel, so you notice they'll never intersect, so that means they are no solution. By the way, if you ever got this and these were the same, then they would be the same line and you'd have infinite solution. If you were back here in number 11, if we'd ended up with negative 4 equals negative 4, That happens all the time, and our answer would have been infinite. So watch for that possibility in the test as well. All right, number 12. Looking here, let's get rid of the x's again. Multiply the top one again by minus 2. That'll give me minus 2x. So we get minus 2x minus 2y equals minus 8. Remember, multiply everything by it. Write the other one down. And now add. These two cancel out. Negative 2 plus negative 3 is negative 5y. Negative 8 plus 3 is negative 5. So when I divide by negative 5, I end up with y equal 1. Well, once again, I could plug that back in and find x, but I don't need to because they just want to know how many solutions they are. The moment I get that answer, I realize there's one solution. Okay? And if we did the other method again, solve for y and compare slopes, x plus y equals 4. So minus x, and we get y equals minus x plus 4. So my slope is minus 1, my y-intercept is 4. Try the other equation, 2x minus 3y equals 3. Subtract 2x, and we get negative 3y equals negative 2x plus 3. Divide by negative 3, everything. And we get y equals, negative by negative is a positive, 2/3 x minus 1. Notice that the slope here, 2/3 and negative 1, that means these two lines have different slopes and they would eventually somewhere cross and have one solution. Okay? All right, let's move on to our graphing. The first one, we're going to graph two equations and find where the point is they intersect. Well, to do this, the first thing I want to do is I want to solve it, put it into the slope-intercept form. So if I take the first equation, x plus y equals 5, let's subtract x from both sides, and we get y equals minus x plus 5. So notice in this form I can see that my slope is minus 1 or minus 1 over 1, which means I go down 1 and right 1. And my intersection here, my y-intercept is b. So let's graph that. Go to the origin and count at 5. 1, 2, 3, 4, 5. There's my y-intercept. I'm going to come down 1 over 1, negative 1. Down 1 over 1 there. And I'm just going to keep doing that. It'll make it easier, make my graph easier. I know it's going to end up there. And I can back up to it this way too. And there. And I can draw my line right there. And that's our first line. All right, second line. So for the second line, let's do the same thing. 2x minus y equals 4. Subtract the 2x from both sides. And we get minus y equals minus 2x plus 4. And now I've got a negative, so let's multiply everything by negative 1. So I get y equals plus 2x minus 4. Okay? So now my slope is 2, or 2 over 1, up 2 over 1, up 2, right 1, always the bottom one right. And my y-intercept is minus 4. So we come down here, 1, 2, 3, 4. And now our slope is 2 over 1, so we go up 2 over 1. Let's keep doing that, up 2 over 1. Oh, by the way, when I do that, I've also found my solution right there already too. And then we'll graph this line as well. And then we can see that our solution is right here. And this is the point 1, 2, 3, x is 3, y is 2, and so our answer here is 3, 2. Okay? Now we go to number 14. Now we have an inequality. So let's begin by, again, we want to graph the boundary line first, which is what would this be if it were 0? So let me just solve them both for y. The first one, I have y plus 2x is less than 6. So I'm going to subtract 2x from both sides. I get y is less than minus 2x plus 6. So a couple of things to notice. First of all, that less than sign means I'm going to shade below, and it's going to be a dashed line because there's no equal. So my slope here is minus 2, or minus 2 over 1, and my y-intercept is 6. So we come over here to 6, 0, 1, up 6, 1, 2, 3, 4, 5, 6. Put our number there, and our slope is negative 2 over 1, so down 2 over 1. So we're going to mark it in here. And now remember, it's a dashed line. So when I go to graph this, we're going to make it a dashed line. Okay? And now it says, we said we're going to shade below. I'm going to use Mr. McClendon's trick. I'm just going to put an X below the line on each end, reminding me that everything's going to shade below. That way I'm not shading everything, I'll just shade my answer. Okay? Now let's do the second one. The second one is already in the equation, y equals mx plus b. So first of all, notice this sign, greater than, means I'm going to shade above, and it's going to be a solid line. All right. My slope here is 1/2, which means down 1 over 2, and my y-intercept is 3. So we come up here to 1, 2, 3. And now we're going to go 1 over 2 slope. So up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. And then backwards as well. Now this time, as we noted, it's going to be a solid line because it's greater than or equal. So we can make a solid line. And then we're going to shade above, so I'll put an X here and an X here. Now what I'm looking for is I'm looking for which section is both above this line and below this line. And I can see by my X's that it's right here. This section here is below this line and above this line. So my answer is to shade in this section right here. This section over here doesn't satisfy either equation. This section satisfies the second equation, but not the first. This one satisfies the first, but not the second. And now they ask you to pick a point. And so just reach in here and grab any point you want, and then count it. 1, 2, 3, 4, 5. That's minus 5. And it's 1, 2, 3. Look, I just randomly picked minus 5, 5. That's not the only answer. Any point in here is an acceptable answer on the exam. Okay? Let's move on down to solving some more algebraically. In the first equation, you can see they've already solved one for x. So when they do that, we think, let's do substitution. Just take that and plug it in for x. So I'm going to write this equation. I'm going to have 2 times, and instead of x, I'm going to put in minus 3y minus 2. And then the minus the 3y equals 14. So first we're going to distribute. 2 times minus 3 is minus 6y. Minus 4 minus 3y equals 14. Combine similar terms, like terms. So we have minus 9y minus 4 equals 14. Undo the minus 4. Now we're to a two-step equation. Add 4. We get minus 9y equals 18. Undo the minus 9 times y by dividing by minus 9. And we get y equals negative 2. Okay? Now, just like before, we're going to take this and plug it back into one of these equations. We might as well plug it into this one. It's already solved for x. X equals minus 3, and we know y is minus 2. Minus 2. So x equals minus 3 times minus 2 is positive 6 minus 2. So x equals 4. So our answer there is going to be minus 2 is going to be 4 minus 2. And then if we want to check our answer, we'll put it back into here. So if I take 2x, 2 times 4, minus 3 times minus 2, does that equal 14? Well, that's 8. Minus 3 times minus 2 is plus 6. And sure enough, 14 equals 14. So I know we got the answer right, x minus 2. Again, remember, just because you solve for y first, don't put it in the first spot. This is always the x, and this is always the y. Okay. Now, 16 is an interesting problem. Some of you, just hold with me. Notice your brain's starting to freeze up because you see a fraction. Don't worry about fractions. First thing we do is get rid of them. I'm just going to get rid of this fraction by multiplying both sides by the common denominator between 4 and 2. 4 goes into 4 and 2 goes into 4, so let's just multiply by 4 and get rid of our fractions. So we end up here with 4x over 4 plus 4y over 2 equals 4 times 2. Or 4 divided by 4 is 1, so I end up with x. 4 divided by 2 is 2. X plus 2y equals 8. Now let's bring our other equation down here. And now I notice I can solve by elimination pretty easily. Notice that if I were simply to multiply this one down here by minus 1, I'll get a plus x and a minus x. So we have x plus 2y equals 8. We didn't do any of that equation. Now minus everything. Minus x, minus times minus is plus 4y equals plus 4. Add them together, that goes away, and I get 6y equals 12. Divide by 6 to undo the 6y, and we get y equals 2. So we have half our answer. And now we'll simply plug it back into one of these equations. I'm going to plug it into this one. X minus 4 times 2 equals minus 4. So x minus 8 equals minus 4. Undo the minus 8 by adding 8. And we have x equals 4. So our answer is 4, 2. If we want to check out our answer, I can do this. I can plug it in there. So x is 4, so 4 over 4 plus y is 2. 2 over 2, does that equal 2? Yes, those are both 1s. So 2 equals 2, and so we've checked our answer and we know it's correct. So that completes that page. Let's move on to the next page. Solve each system algebraically. Okay? So I'm looking here, and I can either get rid of the x's or y's, but I'm looking here and I see that I have a plus and a minus. I don't like to mess with minuses, so I already have a plus and a minus. So if I can just eliminate the y's, I won't have to use any negative numbers. So what I can do is I'm going to multiply the first equation by 3 so that I get 15y. Then the second equation by 5, the opposite of these, and I'll get a negative 15y, then they'll eliminate. So let's do that. So 3 times 3 is 9x plus 15y equals 75. Then multiplying by 5, 10x minus 15y equals 20. We add them up. Sure enough, those eliminate. And now I have 19x equals 95. We divide by 19 to undo the 19 times there. We end up with x equals 5. That's the first half of our answer. So now what we're going to do is we're going to plug that back into one of these equations. So let's plug it into the first one. So 3 times x, or 3 times 5, plus 5y equals 25. So that's 15 plus 5y equals 25. Subtract 15, and we end up with 5y equals 10. So divide by 5, and we have y equals 2. And so our answer is 5, 2. If we want to check our answer, which is always good for a test, plug it into the other one and see if it works. Does 2 times 5, 2 times x, minus 3 times y, which is 2, does that equal 4? Well, let's see. 10 minus 6, and sure enough, 4 equals 4. So I know I did the math right and that we have it correct. Now 18, once again, the brains are starting to cool down. They're thinking decimal, decimal, decimal. What am I going to do? Let's just get rid of the decimal. Okay? So I notice all the decimals are just tenths. 9 tenths, 3 tenths, 5 tenths, 4 tenths. So if it were a tenth, I could get rid of it by multiplying it by a 10. And we'll do it to both of them. When you multiply a decimal by a tenth, it moves over 1. 100 move over 2. So this just simply becomes 4x plus 3y equals 18, and 5x minus 3y equals 9. Now that's really nice, because I'm noticing this is what I call a baby bear problem. Notice I don't have to do anything. If I add them, the y's go away. Cool. So I get 9x, that goes away, equals 27. If we divide by 9, to undo the 9 times x, we get x equals 3. And now we simply have to plug back in. Well, I'm not going to plug in the decimal, although I could. I'm going to plug into one of these equations. They're the same. So 4 times 3 plus 3y equals 18. So 12 plus 3y equals 18. If I subtract the 12, I get 3y equals 6. Divide by 3, and I get that y equals 2. So my answer is 3, 2. If I want to check my answer, I'll do it in the other one. Does 5 times 3 minus 3 times 2, does that equal 9? Well, I get 15 minus 6, and sure enough, they equal, so my answer is correct. And now we have the inequality. Well, first thing we want to do to graph an inequality is put it in the slope-intercept form so we can see how to graph it. The reason we do that is sometimes if we look here, that might be deceptive, because we think we're going to graph lower and equal to, but we have to check it out. So let's just subtract 3x from both sides. And we get minus 2y is less than or equal to minus 3x plus 6. Now we end up having to undo multiply by negative 2, so we multiply by negative, divide by negative 2, everything. And we end up with y, and over here, negative divided by negative is positive, so we end up with 3 halves x, and then 6 divided by 2 is minus 3. Now here's where it's a good thing we did it this way. You have to remember that whenever you divide an inequality by a negative number, the signs switch. So the less than or equal becomes a greater than or equal. So this is one thing you have to be careful when you see them in this form. It may not end up being less than or equal. It could be greater than. So in our case here, the greater than or equal means I'm going to shade above, and it's going to be a solid line. Solid line under it. My slope is 3 over 2, which means up 3, right 2. And my y-intercept is minus 3. So we're all ready to graph. So my y-intercept is minus 3, so we go to the origin and go down 3. And then the slope is up 3 and over 2. So 1, 2, 3 over 2. I want to do it again. 1, 2, 3 over 2. 1, 2, 3 over 2. 1, 2, 3 over 2. Even go backwards. And then we can graph it. Our graph says it's going to be a solid. So I can just go ahead and draw a solid line here. And then we said we're going to shade above. So my answer is to shade everything above. Okay. And there's our inequality. All right, so let's begin with number 20. We have a change purse that has 100 nickels and dimes. The total value is $6. Identify the variables and write a system of equations to model it. Well, first let's identify our variables. I'm going to let N be the number of nickels, just so I can keep them straight. And I'm going to let D be the number of dimes. Now we can always write two equations in the coin problems. The first equation is, what's the number of coins? Well, we have 100 coins, 100 nickels and dimes. Well, I have N nickels plus D dimes equals 100. So the number of nickels and the number of dimes equals 100. The second equation we write is the value of the coins. Now I find it helpful with coins to do it in cents, not dollars. In this case, how much is a nickel worth? It's worth 5 cents. So if I have N nickels, then the value of those nickels is 5 times N. Likewise, my dimes are worth 10 cents each, so if I have D dimes, they're worth 10 cents, and the total is equal in cents, not to $6, but to 600. By the way, if you wanted to write it in dollars, you could do this. You could put 0.05 N plus 0.10 D equals $6. That would be a fully acceptable equation in place of this. I just find most of my students don't like writing with the decimals. It's easier to do it in cents. Now we have an equation we can solve. We could solve it by solving for N or D and doing substitution, but I'm just going to solve it easier. I'm going to take the top equation and multiply by -5 and get rid of my nickels. So let's multiply that across. Minus 5N minus 5D equals minus 500. And then our other equation, we didn't change it. And now we add. The nickels go away as we expected. 10 dimes minus 5 dimes is 5 dimes, and that equals 600, 100. Undo the 5 times D by dividing by 5, and we get D equals 20. So we're going to have 20 dimes here. By the way, part of the answer here was to put our system in here. We should have put N plus D equals 100, and 5N plus 10D equals 600. And now we just have to solve for our nickels. Well, you know, you realize our nickels plus our dimes equal 100. And we said our dimes were 20, so our nickels plus 20 equals 100. So subtract 20, and we get that our nickels equal 80. Now, if I want to check it out, I can do it so. I realize that, let's check the value. 80 nickels, okay, 80 nickels times 5 cents is going to be $4. And 20 dimes times 10 cents is going to be $2. And $4 and $2 add up to $6 as we expected it to. So that's our answer for that equation. Okay? That's our coin problem. So let's go on to the last page. For a party, you can spend no more than $30 on cakes. Chocolate cakes are $5 and vanilla cakes cost $3 each. Identify the variables and write a linear equality that models the situation. So first of all, I'm going to let C equal the number of chocolate cakes. And I'm going to let V equal the number of vanilla cakes. Okay? Now, first of all, the cost of my cake, every cake I have, chocolate cake, costs $5. So the cost of the cakes is going to be $5 times C. If I buy 10 cakes, that's $50. Okay? My vanilla cakes likewise only cost $3, so they're going to cost $3. And I know over here I'm going to have $30. The question is, what's the sign going to be? Well, when I say no more than 30, it means that one thing, it could be 30, that would be fine. But I can't spend any more. So if I tried to spend 31, we go, no, you can't spend 31, no more than 30, but I could spend 29, right? So I can spend 30 or I can spend less than 30. That's what no more. No more than means less than or equal. So our equation is 5c plus 3v is less than or equal to 30. So now we're going to go to our graph. All right? We're going to put down at the bottom the number of chocolate cakes. And on the top here, the number of vanilla cakes. So we need to do our graph here. We could just do 5 and 3. If I want to spread this out, you know what I'm going to do to make it spread out a little bit better? I'm going to go 1, 2, 3. I'm going to let every 2 spaces equal, just so that I use up the graph a little bit better. And so same here, 1, 2, 3, every 2 spaces. If you did every 1, that would be fine. Your graph would just be smaller. You'd like to try to use as much of the graph as possible. Now let's find our intercepts to do this one. So if I want to find the C intercept, all along here, that would be if I bought only chocolate cakes and no vanilla cakes, it would be, I'm going to let the vanilla cake equal 0. So in my equation, 5c plus 3, 0, we're going to find the intercept, so I'll make that an equal sign. Notice that's 0, so I just get 5c equals 30, divide by 5, and we end up finding c equals 6. So the intercept is the point 6, 0. So if I come over here, and notice that makes sense. If I bought 6 cakes at $5 each, I would have spent all my $30, and I wouldn't have any money for vanilla cakes. So 6 zeros that point. Now let's find the V intercept. And for the V intercept, that's as if we don't buy any chocolate cakes. So we're going to let C equal 0. So once again here, now that we're going to have 5 times C equals 0 plus 3V equals 30. So we get 3V equals 30, divide by 3, and V equals 10. Or this is the point 0, 10. In other words, again, if you only bought vanilla cakes, you could buy 10 of them, because 10 times 3 would be 30. So up here at 10, that's how they'd be. And then we'll connect these to get our graph. And then because it's less than, we'll shade everything underneath. And so every line in the shade is a possible solution on what you can spend for the party. By the way, if you pick a point on the line, you will actually spend all of your $30. If you pick a point inside the shaded area, you'll actually end up being able to spend a little less. All right, our last question, or 2 questions. A hotel is offering 2 weekend specials described below. 3 nights and 4 meals for $270, 4 nights and 6 meals for $365. All right. Here's what I like to do. I'm going to let the nights be N and the meals be M. Okay? Nights in, meal. And when you write down explain the variables, you would say let N equal the cost of a night in the hotel. And let M be the cost of a meal in the hotel. That's what they mean by explaining what your variables mean. And now we're going to write 2 equations. Pretty straightforward here, because I can just look at that. 3 nights plus 4 meals is $270. 4 nights plus 6 meals is $365. And there's my 2 equations right there. 3N plus 4M equals 270, and 4N plus 6M equals 365. And the last part is to solve them algebraically. So let's write them down here to solve them. I don't see any way that I can just multiply ones, or we're going to have to multiply both of them. So let's do this. Let's multiply the top one by 4. That's going to get me. I'm going to work on getting rid of these. And the bottom one, because there's both plus, is going to have to be by -3. I could do -4 and +3 as well, just as long as I get a 12 and a -12. So let's multiply through here. 4 times 3 is 12n plus 16m equals, let me get my calculator out for this one, 270 times 4 equals 1080. And then -3, so I get -12n minus 18m equals, and let's do 3 times 365 equals -1/95. Don't lose those negatives. And now we're ready to solve here. So when we add them together, that's eliminated. So -18 and 16 is -2m equals, here we have 1095 -1080 is -15. So when I divide by -2, I find out that my meals are going to cost 7.5. In other words, my meals are going to cost $7.50. All right? Now let's find our nights. So we plug them back into one of these equations. So 3 nights plus 4 times my meal is going to be 270. So 3n plus 4 times 7.5 plus $30 is going to equal 270. Two-step equation now, subtract 30. 3n equals 240. Undo the 3 times n by dividing by 3, both sides. And n is going to equal 80, or $80. All right? Now at this point, if you wanted to check it, you would simply plug it into the other equation. We use this equation to solve it, so we'll use the other one. Does 4 times 80 plus 6 times 750, does that equal 365? Well, 4 times 80 is 320. And 6 times 7.5 is 45. And sure enough, they equal to each other. And we have our solution. All right? And that's the end of the practice test for Unit 4. I hope you do well.